Hello, geometry. So we're going to continue our work with quadrilaterals today and talk about another type of special parallelogram, a rectangle, and then also a square. And before I get started, I'm going to say something that you've probably heard me say before, which is don't forget what you already know. We're going to talk about some things about rectangles and squares that you might not know, but don't forget to rely on your knowledge of what a rectangle and a square actually is. We've been talking about these things since you were a small child and had to fit rectangles and squares into those little shape shorter things. So please don't forget what you already know, okay? Use your instinct as you do some of these problems, and then draw on that instinct and the things I'm about to tell you to finish some problems. So let's get started. What the heck is a rectangle? Well, its base definition is that a rectangle is any quadrilateral with 4 right angles. That's it. That's all you need to be a rectangle. Now, is that all that a rectangle is? No. But the only thing you need is if you have 4 right angles in a shape, it is going to be a rectangle, full stop. Okay? Now, because a rectangle has 4 right angles, it is also a parallelogram because it's a parallelogram if both pairs of opposite angles are congruent, which they are. So it also has all those other properties. So rectangles also have opposite sides that are congruent. It has diagonals that bisect each other. Okay? Opposite sides are parallel, all that other stuff. But if it's a rectangle, it's basically a parallelogram with 4 right angles. All right? So, opening exercise says rectangle ABCD is formed by the lines. Give a justification for why M must be parallel to N, and likewise P must be parallel to Q. So how come if I have 4 right angles, M and N are parallel to each other? Well, here's why. If I look at M and N, and then I compare this angle 1 to that angle 2, I know that angle 1 is 90 degrees. I know that angle 2 is 90 degrees. The measure of angle 1 and the measure of angle 2 are 90 degrees. And I know that 90 plus 90 is 180. And 1 and 2 are supplementary because they add to 180. And then when I look at the positioning in 1 and 2, I have 1 right here and I have 2 right there. Those are same side interiors. And if I have same side interiors that are supplementary, then M and N have to be parallel. M is parallel to N because if same side interior angles are supplementary, the lines are parallel. And that's what I got. Then it says, also show that P has to be parallel to Q. Well, if I kind of turn my head here, I have angle 1 right there. I have angle 3 over here. We can do the exact same thing for 1 and 3. So 1 is 90, 2 is 90, 3 is 90. 1 and 2 are supplementary. Angle 1 and angle 3 are supplementary. And 1 and 3 are same side interiors. Therefore, based on this, P is parallel to Q. No, not P. P is parallel to P because they would be parallel because they have the same slope. But really, I wanted P parallel to Q. All right. So what have we learned in this top half? Really, we just proved that a rectangle is a parallelogram. So we can use all the parallelogram properties as well as the rectangle property we just learned. All right. So now we're going to do a more formal proof using a rectangle here. So it says, given that rectangle MNPQ is a rectangle, prove that MP and NQ, in other words, prove that the diagonals are congruent if you know it's a rectangle. Ooh, so it seems like they're giving us another property. Let's see how we can go with that. Well, if MNPQ is a rectangle, that seems fine. MQ is parallel to NP. They're saying show that this is congruent to that. MQ is congruent to NP. Oh, well, that would be true because opposite sides of a rectangle are congruent. Fine. And then QP is congruent to PQ. Well, wait, QP congruent to PQ. That's the same line twice. So that must be the reflexive property. All right, that seems okay. And now if I look at this, I'm wondering, if I'm headed toward a triangle proof, which it looks like I am, I've only used 3 sides so far. So you know what I'm using? I'm using this triangle right here, MQP, and I'm using this triangle over here, NPQ. I'm using overlapping triangles, and that's why I need a reflexive side. Okay, I can see it. Now it says MQP and NPQ are right angles. So this thing and that thing are right angles. Well, that would be true because it's a rectangle. Rectangles have 4 right angles. And then MQP is congruent to NPQ because all right angles are congruent. And if I look at my picture now, I have this side, I have that side, and I have the angle right between them. So this triangle is congruent to the other one by SAS. And then by SAS, I have congruent triangles, which means all their parts are equal. And MP, let me erase this so I can clearly highlight it here. MP would be congruent to QN by CPCTC. All right, so we just proved that last property of a rectangle. So let's fill in some blanks here. A rectangle is a parallelogram, so there are 5 properties of parallelograms that you always need to remember. Property 1, opposite sides are parallel. Number 2, opposite sides are congruent. Number 3, opposite angles are congruent. Number 4, diagonals bisect each other. And then number 5, which is a property, but I got to be honest, we don't use it that often, that consecutive angles are supplementary. Okay, we don't use that one that often, though. 1 through 4 are definitely your keys. That's true of all parallelograms, so rectangles have that. Rectangles also have 2 additional specific properties. 1, that all 4 angles are right angles. And 2, your diagonals are congruent. Okay. Now, where do I go from here? We just use the properties. Okay? So I'm going to scroll down here and just start using some properties. In rectangle ABCD, the diagonals intersect at E. If AE is 3x plus y, BE is 4x minus 2y, and CE is 20, find x and y. Okay, well, if this is a rectangle and I'm dealing with the diagonals, I know the diagonals of a rectangle are congruent. So there's a couple ways that we can go here. If I know the diagonals are congruent, that means I know BD is congruent to AC. But the other thing I know is that the diagonals bisect each other. So if the diagonals are already congruent and they cut each other in half, I know that this is 20, I know that this is 20, I know that's 20, and I know that's 20. So I can use that to solve for x and y. I know that 4x minus 2y equals 20. I know that 3x plus y equals 20. And then I realize I have x's and y's. So I really need to be able to solve this system, to solve a system of equations. I think in this case, I'm going to do substitution. I'm going to get this thing in y equals form. So I have y equals 20 minus 3x. I'm going to put that in here for y. So I have 4x minus 2 times 20 minus 3x equals 20. And now I'm just going to do some arithmetic here. So I have 4x minus 40 plus 6x. 4x and 6x is 10x. Add 40 to both sides. I'm just solving for x here. And after all that work, I'd get x equals 6. Okay, cool. Well, if x equals 6, I still need y. So I'm going to bring that 6 over to here. And y equals 20 minus 3 times 6, which would be 3 times 6 is 18. 20 minus 18 is 2. So y is 2. And then I should check my answer. So if x is 6 and y is 2, 4 times 6 minus 2 times 2 is 24 minus 4. Yep, that's 20, so this one works. And then 3 times 6 plus 2 times 2 would be, not 2 times 2, would be just 2, pardon me. 3 times 6 plus y, which is 2, is 20. And that one works. Okay, and here's another one of those where I just give you a picture and I say, hey, here's a picture. Have at it. So I'm going to have at it. Cn is 15. All right, Cn is 15. So I'm going to put that on that diagonal there. And then KL is 18. Kn is 24. And they want me to find a bunch of other stuff. Okay. And, an angle 1 is 70. I forgot to write that in there. Okay, 70 right here. Cool. Well, I'm going to zoom in so I can ignore everything except for the diagram and say, well, if this is a rectangle, if the left-hand side is 24, so is the right-hand side. If the top is 18, so is the bottom. If this is a rectangle, I also know that these diagonals cut each other in half and are the same length. So if this is 15, so is that, and so is that, and so is that. And then if angle 1 is 70, if these are both 15 right here, that means this triangle is an isosceles triangle. So if I have 70 in angle 1, I also have a 70 in angle 8. And then 70 plus 70 is 140. So this has to be 40. Then I got some vertical angles here, so that's 40. And this 40 with angle 10 has to add to 180 because they make a straight line, so that's 140. And if this is a rectangle, these corners are 90 degrees, so that means angle 7 is 20. And 20 plus 140 is 160. So I got another 20 down here. I got another 90, so that's got to be 70. And I'm realizing, oh, all of these are 70 and 20. And now I have everything marked. Woohoo. Awesome. Okay. Cool, cool, cool. Now I'm just supposed to fill in the blanks. So CK. C to K is 15. Fine. Let's see. KM. KM is 30. NM is 18. ML is 24. CL is 15. CM is also 15. Now, before I move on, the math teacher in me is really a little bit frustrated right now because I gotta tell you that this is not a very good diagram. Now, the reason I know this is a very good diagram, isn't a very good diagram, is because the angles are definitely going to be off. The reason I know that is because in this triangle up here, If I look at this triangle right here, when I knew that angle 1 was 70, I have a 70-degree angle across from a 15 and a 40-degree angle across from an 18. It would not work like that, okay? The bigger angle should have a bigger side across from it, but we fudge the numbers a little bit to make these whole numbers to make them easier to manipulate. Okay, so FYI, this is not drawn to scale, and the angles and the sides don't really work out, but we use the properties appropriately, and it's okay. I just had to put that little side note in there because as I'm drawing this, I'm remembering that we kind of fudge the numbers a bit, and I wanted to be honest. Okay, now, I've been recording for a while. The next thing we're going to talk about is squares. So if you can hold on with me, we're going to talk about squares, and I'm going to try to do it as quickly as I can because you all know what a square is. A square is the thing you see right here. A square has both 4 right angles and 4 congruent sides. Okay, you know that. That's what a square is. It's got 4 equal sides and 4 right angles. It has to have both, though. You can't just think that a square is something with 4 equal sides. That's not it. 4 equal sides makes it a rhombus. If you have 4 equal sides with 4 right angles, then you've got a square. Okay? Since a square has 4 congruent sides, it is also a rhombus. It has 4 right angles, so it's also technically a rectangle. And it has congruent opposite sides, so it's also a parallelogram. Okay? A square is a specific type of each of those 3 things. Now, a square has many different properties. Because it's a parallelogram, it has all 5 parallelogram properties. The parallelogram properties being opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals that bisect each other, and it has consecutive angles supplementary. Those are all the parallelogram properties. Not only does it have the parallelogram properties, it has the rectangle properties that we just talked about. The rectangle properties were all 4 right angles and diagonals that are congruent to each other. Okay? And it has a property of a rhombus, and the rhombus properties were that it has all 4 sides equal. The diagonals are, they form right angles. I forgot to write form. Diagonals are perpendicular. They form 4 right angles. And all 4 sides are congruent. The diagonals are perpendicular. And what's the other one? The diagonals bisect the angles. And this is a great image right here, this box, to remind you of the properties for specific things. Parallelograms have 5 properties you need to know. Rectangles have 2 properties you need to know. Rhombuses have 3 properties you need to know. And since a square is all of them, it has all of those properties. All right. So we're going to come down here and just play with a diagram for a moment. Given square ABCD, you know that AC is 12. Find the length of AD in radical form and find the measure of all the angles. Okay, I'm going to deal with the angles first. Well, if this is a square, that has to be a right angle. But since a square is a rhombus, the diagonals bisect the angles, so that means these are both 45. And that is true in every single corner. Also, since a square is a rhombus, the diagonals are perpendicular, which means that these are right angles. If I can get that to work right, there we go. And now we can deal with the fact that AC is 12. So if AC is 12, this is 6 and 6, and that's 6 and 6. And I know that because A square is a rectangle, which means the diagonals are congruent. And then they want us to find the length of AD. Okay, well, this is a right angle, and AD is up here. So I have a right triangle, and I can do Pythagorean theorem to find the hypotenuse. So I have 6 squared plus 6 squared equals c squared. 36 plus 36 is 72. So c is the square root of 72. And since it's a square, they are all that long. And there's all my square stuff. Okay. Now, the last thing that we are going to talk about is kind of what we call like the hierarchy of quadrilaterals or the quadrilateral family tree. Okay. So a quadrilateral is anything that has 4 sides like that. If you have a quadrilateral where adjacent sides are equal, but not opposite sides are equal, that's called a kite, by the way. A trapezoid has at least 2 pairs of parallel sides. There are funky trapezoids, and then there are isosceles trapezoids. And then the place that we just dealt with all of is this parallelogram part. A parallelogram is one of your generic forms. Okay, so like a slanted parallel thing is a parallelogram. If it's still a parallelogram, but it's not so slanted, then it's a rectangle. If it's a parallelogram and it's slanted, but all 4 sides are equal, then you have a rhombus. And if you have a rhombus rectangle hybrid, you get a square. Okay. So make sure you know the properties. The best way to know those properties is probably to find a way to memorize this box. And then you can do some sometimes, always, never. And I'm done with the video right after this, I promise. So sometimes, always, never. A square is a rectangle. Well, a square always has 4 right angles. A rectangle always has 4 right angles. So a square is a rectangle always. Okay. A trapezoid is a parallelogram. Well, a trapezoid has to have 1 pair of parallel sides. A parallelogram has 2 pairs of parallel sides. So a trapezoid can technically sometimes be a parallelogram because there are some definitions of a trapezoid that says a trapezoid has at least 1 pair of parallel sides. So a trapezoid can sometimes be called a parallelogram. A rectangle is a square. Well, a rectangle has to have 4 right angles, but it doesn't have to have 4 equal sides. So sometimes a rectangle can be a square. And then rhombuses are squares sometimes because a rhombus has to have 4 equal sides. But if it's a rhombus that has 4 equal sides and 4 equal angles, then it would be a square. All right. And you can do that by looking at the chart. A square is below a rectangle, so a square is always a rectangle. A rectangle is a square. Well, that would be sometimes because they are connected. Okay. That's kind of how I'm thinking about it. And with that, I am going to stop. It's already long enough. So hopefully you now know properties of rectangles and squares. Don't forget to use this chart as much as you possibly can. And then you guys are going to do some practice. Have a great day.